Welcome everybody to Algebra 2, Section 5.5, Solving Polynomial Equations by Factoring. So remember that solving these is finding the roots, zeros, x-intercepts where it crosses the x-axis. And in order to do that, we set the y value equal to 0, the equation equal to 0, because we know that the y value must be 0 when we have an x-intercept. So our first step is to move all terms to one side and set the equation equal to 0. Then we're going to factor the polynomial as much as we can, and then set each of the factors equal to 0 and solve for the x values. Now, when you get it down to a quadratic equation, something with a highest exponent of 2, you can solve by square roots, complete the square of the quadratic formula, and we're also going to be simplifying all irrational and complex solutions. We'll talk about that as we go through this. So, number 1, we have this equal to 0 already. I always look for a GCF first. That's what we're supposed to do. So our GCF here is x. And we get x squared plus 1 equals 0. So at this point, I can establish that my two factors are x and x squared plus 1. If I could factor x squared plus 1 further, I could go ahead and do that. Or I could just start setting equal to 0 and solve by square rooting if I'd like. Since that is lacking a b term. That's a requirement for solve by square rooting, is that it has no b term, no bx. And I can't factor this further anyway because it's a sum of two squares, which is not one of our factoring rules. We have a difference of two squares. So I'm going to go ahead and set x equal to 0 and x squared plus 1 equals 0. And this first one is obviously already solved for that it's x equals 0. This other one, though, I'm going to subtract 1 from each side, so we get the x squared, the squared term isolated. And I'm going to go ahead and square root both sides, and the square root of negative 1 is positive negative I. Positive negative in between step here would be x equals positive negative square root of negative 1. Actually, not even an in-between step. I was thinking that would be like the square root of negative 1 times square root of 1, but I guess that's quite unnecessary because just the square root of negative 1 is I. And whenever you square root both sides of an equation, you get a positive negative version. So our three answers are 0, positive I, and negative I, which you could write like this, or you could choose to write as positive negative I, comma 0, or 0, comma positive negative I. Either one is perfectly fine. On to number 2. So we first have to set this equal to 0, so I'll do that by subtracting 3x squared from each side. That does combine with negative 7x squared, giving me 4x cubed minus 10x squared equals 0. So now I look for a GCF. The GCF is 2x squared, and I'm now left with x minus 5 equals 0. So now I can set each of these equal to 0. 2x squared equals 0. X minus 5 equals 0. This couldn't be factored further even if we wanted to, since it's not a difference of two squares or a difference of two cubes. So then here I divide by 2. X squared equals 0. Then I square root both sides, and I get x to equal positive negative 0, which is just 0. And then on this other one, I add 5, and I get x to equal 5. And so we have 0 and 5 as our two answers. I made a mistake here, my apologies. This was not x minus 5 there. That should have been 2x minus 5. And so then we still need to divide by 2, giving us x equals 5 over 2, or 2.5. On to number 3 here. We set it equal to 0, already done. Look for a GCF, there isn't one. This is, however, a difference of two squares. X to the fourth is a perfect square, x squared times x squared, and 64 is a perfect square, 8 times 8. 64 is a perfect cube as well, but it's not a difference of two cubes because x to the fourth is not a perfect cube. So we do x squared minus 8, x squared plus 8 equal to 0. And because we have no b term for each of these, I can just go ahead and set these each equal to 0. X minus 8 equals 0. X squared plus 8 equals 0. And now I can go ahead and solve by square rooting. So I'll add 8 to each side and get x squared equals 8. Square root both sides. And this doesn't simplify, so I'm just going to call it positive negative square root of 8. So that's 2 of my answers. So then we subtract 8, and we get negative 8. Then as I square root this, I get a very similar answer, but it's plus or minus I square root 8. So those are the 4 answers. Oh, I said I couldn't simplify that. Silly me. I definitely can simplify these. And I do need to simplify them because I can. So this simplifies to x equals positive negative square root 4 times square root 2, which is really square root 2, or 2 square root 2. And so then this other one will simplify very similarly to positive negative 2i square root 2. And those would be our 4 answers. On to number 4. It is equal to 0. We look for a GCF. There is one, it's 5x. So I'm left with x to the 4th minus 16. This is a difference of 2 squares. I know to look for that because it's 2 terms. So when it's 2 terms, I always look for difference of 2 squares, sum of 2 cubes, sum of difference of 2 cubes. And this is x squared times x squared and 4 times 4. So the 5x gets written out in front. And I have x squared minus 4 as well as x squared plus 4 equals 0. And I have a choice here. I can either set each of these equal to 0, which is what I'm personally going to choose to do, and then start solving, because I can solve each of these latter 2 by square roots. Or I could take this and I could factor this further as another difference of 2 squares, and then set each of those equal to 0 instead of x squared minus 4 equals 0. It's a matter of preference. So personally, I would rather just solve this by square rooting as soon as I can get to that opportunity. So I divide by 5 in this first one and get x equals 0. In the second one, I add 4 and get x equals 4. And the last one, I subtract 4 and get x squared equals negative 4. In both the second to last and the last, I need to square root both sides. The middle one gives me positive negative 2, and the last one gives me positive negative 2i. So my 5 answers are 0, positive negative 2, and positive negative 2i. On to number 5. It is equal to 0. There is no GCF. I do want to look for potentially perfect cubes or perfect squares, but it's not a subtraction, it's addition, so it can't be perfect squares. And so x cubed is x times x times x, and 125 is 5 times 5 times 5, so they are perfect cubes. And so we can do a sum of 2 cubes. Reminder, that's x plus 5, x and 5 serving as a and b respectively. So it's a plus b, in this case x plus 5, times the quantity of a squared, or x squared, minus a times b, so minus x times 5, or 5 times x, plus b squared, which would be 25 squared, or excuse me, 5 squared, which is 25. So I can solve this first one pretty easily by setting equal to 0. But if I set this other one equal to 0, I actually can't solve it yet by normal methods. I can't do it, not by normal methods, I should say, not by square rooting, because it does have a bx term. I'll have to either use the quadratic formula or complete the square, since I actually can't factor this any further. If I tried to factor this by making the x, I would find that I would get nothing to finish the sides of the x. So the first equation, I'll just go ahead and subtract 5 and get x equals negative 5. For the second one, I have to determine, do I want to use the quadratic formula or complete the square? And a good rule of thumb is to determine whether the b is even or not. And since b is not even, it is odd, and I know that for complete the square I will need to divide by 2, I will choose to do the quadratic formula. So I'll get x equals negative of b. Reminder, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So I will have here negative of negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times 25 all over 2 times 1. And so that becomes a positive 5 plus or minus the square root of 25 minus, that was wonky, 25 minus 100 all over 2. So that's x equals 5 plus or minus the square root of negative 75 all over 2. 5 plus or minus, that's square root of 25 and square root of 5, so that's 5i, because it's the square root of a negative number. Square root 5 over 2. Sorry, not square root 5, square root 3, because it's 25 times 3. And those are 2 answers, as well as x equals negative 5. In the orange, I can't simplify any further. If I could simplify this complex answer further, I would. All right, moving on to number 6. I'm going to set this equal to 0 by subtracting 4x squared. That combines with 5x squared to get me 8x to the 5th plus x squared equals 0. My GCF is x squared. Always look for 1, and I have 8x cubed plus 1 equals 0. Since this is cubed and not squared, I can't just set that equal to 0 and solve. I instead need to, or at least by our current methods can't. There is actually a method you can, but with where we're at, we can't. So instead I look to continue factoring it, which I can. It is a sum of 2 cubes. I look for that because it's adding and there's 2 terms. So this is 2x being cubed as well as 1 being cubed. So that will serve as a and b. So I'll have this part becoming 2x plus 1, 2x squared, which is 4x squared, minus 2x times 1, which is 2x, plus 1 squared, which is 1. And that's with the x squared out in front. And now I can set each of these 3 terms equal to 0. So I can set x squared equals 0, I can set 2x plus 1 equals 0, and I can set 4x squared minus 2x plus 1 equals 0. And so now this first one is, well, pretty easy to solve, all things considered. By just square rooting both sides, I get x equals 0. It can't be positive or negative. So that's one answer. The other one, I subtract 1 and divide by 2 to get negative 1 over 2. Once again, not bad. This last one, if I were, even though the b is even, completing the square is not a great option here because I would have to divide by 4 first and then making it a fraction, and that's going to get quite messy. Very doable, just messy. So I'm going to prefer to use the quadratic formula here. I can't factor it. If I were to try to make the x, I would once again find that it would fail here. So I'll plug this into the quadratic formula. X equals negative of negative 2 plus or minus the square root of negative 2 being squared minus 4 times 1 all over 2 times 4. So that's x equals 2 plus or minus the square root of 4 minus 16 all over 8. And so that's x equals 2 plus or minus the square root of negative 12 all over 8. The square root of negative 12 does simplify into the square root of 4 and the square root of 3 and the square root of negative 1. So that's 2i square root 3 all over 8. And we can simplify 8 with each of those 2's, so we will, giving us x equals 1 plus or minus 1i, or just I, times the square root of 3, all over 4. And those will be our last 2 answers. So we got 4 total answers, which once again you could write as a list with commas or as separate boxes like I did here. Moving on to number 7. It's already equal to 0. Exciting stuff. So now I'll look for a GCF. There is none. There's 2 terms, so I look for either a difference of 2 squares, difference of 2 cubes, or sum of 2 cubes. It is subtraction, and this is a perfect cube, and so is 216. So the cube root is x and 6, so I'll follow that pattern. X minus 6 for the first parenthesis, a squared, which is x squared, plus a times b, which is 6 times x, plus 6 squared, which is 36. Notice the signs are different than my previous ones because this is a difference of two cubes, not a sum of two cubes. And so now I can set each of these equal to 0. Solve the first one by simply adding 6. The second one, however, I will need to use completing the square or quadratic formula. I can't factor this further. Once again, the x would not work. And so completing the square is going to be my choice here because our b is even and our a is already just 1. So I'm going to choose to subtract 36 from both sides and then add a blank on each side, which that is going to be found by doing half of my b term and squaring it. Half of 6 is 3. Squaring 3 is 9. And so that'll lead me to x squared, the left side will factor into x and then half of b, so x plus 3, quantity squared, and the right side is negative 27 as we combine like terms. Now I will square root since I have completed the square and get x plus 3 equals positive and negative, and this simplifies to the square root of 9 times the square root of 3 times the square root of negative 1, or 3i squared root of 3. I will now subtract 3 and be done with the problem, giving me negative 3 plus or minus 3i squared root of 3. Holy threes. And so those are my second and third answers alongside x equals 6. Number 8 here, I first need to get this equal to 0, so I subtract 54. I then look for a GCF. There is a GCF. It is 2. So I'm left with 8x cubed minus 27. Since it is cubed, I can't progress unless I'm able to find a further way to factor this. These are both perfect cubes, so it's 2x is a cube root and 3 is the cube root. And so I'll follow that pattern of doing 2x minus 3, 2x squared, quantity squared, which is 4x squared, plus a times b, or 2x times 3, which is 6x, plus b squared, which is 3 squared, which is 9. Now, as I set these each equal to 0, 2 cannot equal to 0, so I can rule that one out. 2x minus 3 equals 0, and 4x squared plus 6x plus 9 equals 0. So this 2x minus 3 equals 0. I will add 3 and divide by 2 to get me x equals 3 over 2. In the other one, I don't want to use, I can't factor, it won't work. I could do completing the square quadratic formula because they work all the time. Completing the square would get messy because you'd have to divide by 4, thus leaving you with a fraction for b, which I'd rather not. And so instead I will then just, as I mentioned, do the quadratic formula. So x equals negative of 6 plus or minus the square root of 6 squared minus 4 times 9 all over 2 times 4. And so that's negative 6 plus or minus the square root of 36 minus 144 all over 8, which is x equals negative 6 plus or minus the square root of negative 108 all over 8. The square root of negative 108 does simplify into the square root of 36, square root of 3, and square root of negative 1. So this is negative 6 plus or minus 6i square root 3 all over 8. And we can reduce all 3 parts by 2. 1, 2, 3 parts. And get x equals negative 3 plus or minus 3i square root 3, again with a lot of 3's, all over 4. So we ended up with 3 answers, 2 that you see right now, as well as our other one of 3 halves that we found earlier. On to number 9. It is equal to 0. I look for a GCF. There is none. I will go and make the x since there's 3 terms. I will get a times c, which is 1 times negative 42 on the top, and b on the bottom, which is 1. I do find that negative 6 and positive 7 do the trick. Since a is 1, I can use my shortcut. So I'll have x squared, half of this exponent, minus 6, and x squared plus 7 equals 0. I can set these each equal to 0. I also can't factor them any further. And now I can solve them by square rooting because there's no b term, which I love being able to solve by square rooting, much faster than the quadratic formula or completing the square in my opinion. So I'll add 6 and get x squared equals 6. I'll subtract 7 and get x squared equals negative 7. And as I square root, I get x equals positive negative square root of 6, which does not simplify. And I get x equals positive negative I square root 7, which also doesn't simplify. On to number 10. Setting this equal to 0, I will add 9x to the fourth on both sides and subtract 13 on both sides, giving me 10x to the fourth minus 10 equals 0. I have a GCF of 10, so I'll factor that out, give me x to the fourth minus 1 equals 0. This is a difference of two squares. X to the fourth is a perfect square, x squared times x squared, and 1 is a perfect square, 1 times 1. So I'll have 10 out in front, and I'll have x squared minus 1, as well as x squared plus 1, with either parenthesis coming in either order. And I could factor this one further into x minus 1 and x plus 1. However, personally, I just prefer to go ahead and start solving by square rooting at this point. So 10 equals 0. Nope, it doesn't. X squared minus 1 equals 0. X squared plus 1 equals 0. And I'll go ahead and work on solving this by adding 1 to each side in this middle equation and subtracting 1 on each side in the last equation. And then the square rooting, giving me x equals positive negative 1, as well as x equals positive negative I for my 4 total answers. Moving on to number 11 here. We do have it equal to 0. What a convenience. We do look for a GCF. It is x. So I will have x squared minus 8x plus 16 equals 0. I personally will look to see if I can factor this further. Before I said I can't, so I didn't bother. But here I can factor this one further, and I will. If this had no bx term, I would just square root it and move on my way. Or set it equal to 0 and then square root it. But I'd rather factor than do the quadratic formula completing the square when I can. So a times c is 1 times 16 on the top, and negative 8's on the bottom. And I do find that negative 4 and negative 4 do the trick. And I can use a shortcut since a equals 1. So I'll have x. Sorry, let me try that again. No, that's correct. I thought I made a mistake, but I didn't. So x minus 4, as well as x minus 4 once again. So if I set each of these equal to 0, I'll notice that my second and third equations are exactly identical, and so when I solve them, I'll get x equals 4 each time. Which if you want, you could box all 3 of these, or you could just do x equals 0, x equals 4, or an ordered pair of x equals 0, 4. Not an ordered pair, excuse me, but a list. So any of those would be perfectly fine. The green, the first red, or the second red. Looking at number 12 here, this is equal to 0. There is a GCF. It is 2x squared. And I'm left with x to the fourth minus 5x squared minus 24. I will look to factor that since it's a trinomial. And I'll have negative 24 at the top, negative 5 at the bottom, and I find that negative 8, positive 3 do the trick. And I can use the shortcut since it's a 1 for the a. So I have 2x squared in front, x squared minus 8, remember half that exponent, and x squared plus 3. And now, since neither of these second parentheses have b terms, I'm just going to go ahead and set them equal to 0 and solve by square rooting. They also don't factor even if you do try. And so I divide by 2 in this first equation, get x squared equals 0. add 8 in the middle equation, get x squared equals 8, and subtract 3 in the last equation, get x squared equals negative 3. So now as I square root the first one, I get x equals 0, cannot be positive or negative. Subtract the square root in the other one, I get x equals positive negative 2 square root 2 as it simplifies. And square root in the last one, and get x equals I times, try that again, positive and negative I square root 3 as our 5 answers. On to number 13. I should address actually, here you see 5 answers with an even largest degree, and we talked about how when the largest degree is even, that you'd have an even number of roots, and you do technically have that because this is what we call a double root. You ended up having 2 of your answers being 0 since it can't be positive nor negative. And so while it looks like 5, it's technically 6 because x equals 0 is repeated. We just don't write it that way. On to number 13, we need to set this equal to 0 by subtracting 8. So I get 3x to the 4th plus 2x squared minus 8 equals 0. There is no GCF, unfortunately, so I'll go ahead and make my x, knowing that I would have to go the long way of splitting and grouping. So I have negative 24 on top as I do a times c, and I have positive 2 on the bottom. And I notice here that negative 4 and positive 6 do the trick. Can't use the shortcut, so I rewrite the first term, rewrite the last term, and I split the middle term using the x squared. So negative 4x squared plus 6x squared in the middle. And now I group first 2 and last 2. And the first 2 have a GCF of x squared, giving me 3x squared minus 4. And the last 2 have a GCF of 2, giving me 3x squared minus 4. Those parentheses match, which is good. If they didn't, we did something wrong. So that becomes one of my factors. And my other factor is what I factored out already, of x squared plus 2. And because I have binomials that are quadratics, highest exponent of 2, and there's no b terms, I'm going to choose to go ahead and set these equal to 0 and solve by square rooting. Once again, if you tried to factor, it also wouldn't work. You could do the quadratic formula as well as complete the square if you really wanted to, but this will be much easier for me. I guess complete the square is kind of hard to be 0, so you're really just square rooting and skipping the step when I think about it. So I add 4, divide by 3, and I get x squared equals 4/3. We must add and divide before square rooting, and because the square term has to be by itself. So we get x squared equals negative 2 in the other one. And now I will square root both sides and get x equals positive negative 2 over square root 3, which we'll need to rationalize. And then here, I end up, I got 2 on the top, by the way, by square rooting 4 to clarify. I get x equals positive negative I times square root of 2 for my other 2 answers. I noted I still need to rationalize here. What that means is that we don't want to leave our answer with a radical in the denominator, just like we don't want to leave our answer with imaginary numbers in the denominator. So I need to multiply by the square root of 3 on the top and bottom, the square root of whatever number it is, and that gives me x equals positive negative 2 square root 3 over regular 3. Square root of 3 times square root of 3 is regular 3. Square root of any number times square root of any number, that same number is just that number itself. And that is number 13. On to number 14. I need to subtract 2x and 18 from both sides in order to get this equal to 0. So I'll have 5x cubed minus 3x squared plus 30x minus 18. I look for a GCF, but there is none. I do then have 4 terms, so I will group first 2 and last 2 and look for GCFs. X squared is a GCF of the first, giving me x minus 3. GCF of the second is 6, giving me, try that again. Oh, silly me. I see what I did wrong. This was a 5x cubed, and for whatever reason, I just disregarded the 5. So the GCF was 6, like I thought, and I get 5x minus 3, which now matches. I was getting hung up because I knew I was going to get 5x here, and that didn't match what I had here. So I had to go back and fix that. And now since those match, that becomes one of my factors. And my other factor is x squared plus 6, what I had already factored out as GCFs. Since this doesn't factor as well as the fact that I can solve by square rooting, I'm going to go ahead and set each equal to 0. Let me clarify this is minus. And I'm going to add 3 and divide by 5 and get x equals 3 over 5. Subtract 6 and I get x squared equals negative 6. Square root both sides and get x squared equals positive negative I square root 6, which does not simplify any further. And now I'm on number 15. It is equal to 0. There is no GCF. So since I have 4 terms, I'll go ahead and group. Put the first 2 in a parenthesis, the last 2 in a parenthesis. The GCF of the first 2 is x squared, and I get x plus 2. GCF of the last 2 is 5, and I also get x plus 2 again, which is good that they match. And so I put x plus 2 as one of my factors, and the GCFs I factored out of x squared plus 5 as my other factors. I'm going to set each of those equal to 0 for the reasons I mentioned before of x squared plus 5 cannot be factored further, as well as I can also just solve by square rooting now. So I subtract 2 in my first equation and get x equals negative 2. I subtract 5 in this next equation and get x squared equals negative 5. I will then square root both sides and call this plus or minus I square root 5. Simplifying the square root negative 1 to be I, but I can't simplify the square root of 5 any further. On number 16, it is equal to 0. There is no GCF. And since there's 4 terms, I will group the first 2 and the last 2. GCF of the first 2 is x squared. My iPad went rogue there. And I'm left with 2x minus 3. GCF of the last parenthesis is negative, because it starts negative, and we want it to start out positive. 16. I'm left with 2x minus 3. If you're ever stuck on what the GCF of the second one might be, remember that you have to match this. So as long as you do this right, you can use this to your advantage. And I had said, okay, in order to get this to be 2x, I will have to divide by 16. And now I can continue by doing 2x minus 3 for one of my factors and x squared minus 16 for my other one. I could continue factoring x squared minus 16 into x minus 4 and x plus 4, but because I can go ahead and start solving by square rooting, I just prefer to do that personally. So I have 2x minus 3 equals 0, x squared minus 16 equals 0, and the first one I add by 3 and divide by 2 and get x equals 3 over 2. The second one I add by 16 on both sides and get x squared equals 16. I will then square root it on both sides to undo the square, giving me x equals positive negative 4. On number 17 here, we start with doing some word problems. Our favorite. A rectangular prism with the dimensions of x minus 3, x minus 1, and x minus 8 has a volume of 33x cubic units. For reference, volume of a rectangular prism is length times width times height. And so side times side doesn't really matter which one's the length, width, and height for each of these 3 parentheses. And we're wanting to find the dimensions, length, width, and height of each of the 3 sides. And so what we're going to have to do is set this to be 33x, our volume, equals the multiplication of each of these parentheses, x minus 3, x minus 1, and x minus 8. And in order to solve these, I remember that I need to get it equal to 0, but before I can subtract 33x from both sides, I need to expand this by multiplying these all out. So I'll do multiplying of the first 2, which gives me 33x equals x squared minus 3x plus 3 times x minus 8. I will combine these before multiplying further to make my life easier. I get x squared minus 4x plus 3 times x minus 8. And now I'll multiply here to everything, giving me x cubed minus 8x squared minus 4x squared plus 32x plus 3x minus 24. And so now as I clean this up by combining like terms, and I'll go ahead and subtract 33x at the same time, I will get 0 equals x cubed minus 12x squared plus 2x. Can't forget about this minus 33x impacting that as well, minus 24. And so now that I have this equal to 0, I can now look to factor. And so I have 4 terms, no GCF, so I'm going to factor by grouping, giving me 0 equals, and then factor out an x squared at my first parenthesis, giving me x minus 12. Then I'll factor out 2 of my second parenthesis, giving me x minus 12 again. Those match. So I have 0 equals x minus 12, as well as x squared plus 2. So I can set each of these equal to 0. So the first one ends up giving me 12 as I add 12 to both sides. And the second one I can notice is going to be an imaginary solution, since I'm going to have to square a negative number. And I can just disregard it at that point, even though I know that it'll end up being positive negative I squared 2. I can disregard that as one of my answers because we're dealing with real side lengths here of the length, width, and height of this rectangular prism, and we can't have imaginary or lateral numbers be side lengths. So x equals 12. Whew. So now I need to find the dimensions by plugging 12 into each of these 3 sides. So 12 minus 3, 12 minus 1, and 12 minus 8. That'll give me the results of 9, 11, and 3. So it is 9, whatever units we're using, 11, whatever units we're using, and 3, whatever units we're using. It doesn't specify, so I'll just say units. That is a beefy problem for sure. Moving on to number 18 here. The area of a trapezoid is 30x plus 20 square feet. Find the area. So it's important to know the formula for this is area equals 1/2 times the height times base 1 plus base 2. So one of our bases is x plus 5, another base is 5x minus 1, and our height is x squared plus 1. So we'll plug in all of these figures and start expanding just like we did in the previous one. So plugging this all into the formula, it'd be 30x plus 20 for area equals 1/2 times x squared plus 1 times x plus 5 plus 5x minus 1. You could certainly put the bases in their own parentheses if you'd like, but I'd rather not personally. I think it makes it a little more messy. And so I'll expand the right-hand side. I will wait to multiply by 1/2 because it's not very convenient to do it right now with the numbers I get. And if I combine like terms here, I end up getting 6x plus 4. And I'm going to go ahead and do 1/2 times that to make my life a little bit easier, since those are both even. And I'll have x squared plus 1 times 3x plus 2. And now I'll multiply those together, giving me 3x cubed plus 2x squared plus 3x plus 2. And now if I subtract 30x and 20, I get 0 equals 3x cubed plus 2x squared minus 27x minus 20, so minus 18. So I finally have this equal to 0. I have 4 terms, no GCFs, so I will go ahead and group first 2 and last 2. And I will get 0 equals the GCF of x squared 3x plus 2 is what's left. The GCF of negative 9, 3x plus 2 is again what's left. I will then have 3x plus 2 as one factor, and x squared minus 9 is my other. So I will go ahead and start solving this, and I get 3x plus 2 equals 0. X squared minus 9 equals 0. Remember, I could factor this further if I'd like to, but I just preferred not doing that. So this first one, I subtract 2 and divide by 3, giving me negative 2/3. A side length, again, can't be negative, and if I were to plug in x here to some side lengths, I would get negative numbers. So that can't be it. Specifically the bottom of the two bases. This other one, I add 9 and get x squared equals 9. I then square root, and I get x equal positive negative 3. Once again, can't be the negative version, so x is just simply 3. So, to find the area of the trapezoid, I plug it back into 30x plus 20. So 30 times 3 plus 20 is 90 plus 20, which is 110 square units, which is feet, so square feet. Let's move on to number 19 here. So the revenue R in thousands of dollars for a small business can be modeled by the following equation, where T is the number of years since 1995. In what year did the revenue reach 75,000? So remember that we're doing in thousands of dollars. So 75,000 is really just going to get plugged in as 75 because the 75 thousands of dollars. So 75 will replace R of T, or the revenue, where T is the time in years. So we're going to do is 75 is equal to the rest of the equation of 2t cubed minus 12t squared plus 3t plus 57. Now, in order to solve this, just like before, we need to get it equal to 0, so we'll subtract 75 from each side, giving us 0 equals 2t cubed minus 12t squared plus 3 minus 18. Now, since we have 4 terms, we check for a GCF. There is none, so we'll go ahead and factor. Group the first 2, group the last 2 when they have 4 terms. Look for a GCFs of each group. The first group has a GCF of 2t squared, leaving us with t minus 6 inside. The second group has a GCF of positive 3, leaving us with, as it's supposed to be a 3t, so leaving us with t minus 6. Those match, that's good. If they don't, we did something wrong. So we have t minus 6 as one factor, and 2t squared plus 3 as our other. I'm making sure to have my t's have tails at the bottom to differentiate them from the plus signs. And so now I can set each of these factors equal to 0. T minus 6 equals 0, and 2t squared plus 3 equals 0. T minus 6 equals 0 is solvable by adding 6 to both sides, giving us t equals 6. And this other one, as we start solving it and getting t squared by itself so we can square root, we get negative 3 over 2 by subtracting 3 and dividing by 2. If we were to square root this one, we'll notice we get an imaginary solution, or 2 imaginary solutions, which can't be the answers. It ends up being, in case you're curious, plus or minus, and after we rationalize it by multiplying by square root of 2 and square root of 2 and all of that business, I square root 6 over 2. But once again, can't be those because you can't have imaginary years. And so the answer then is 6 years. And we asked what year did the revenue reach 75,000, and it's years since 1995. So 6 years after 1995 is 2001. Number 20 here to wrap up this lesson. The population of a species is modeled by the following equation, where t is the number of years, and this p would be representing the population at that time. Approximate the number of years until the species is extinct. Well, if it's extinct, how many people are in how many of the species, let me ask this again. How big is the population? Well, that would be 0 for the population. So we replace p of t, that entire left-hand side, with 0. So 0 would equal negative t to the 4th plus 72t squared plus 225. And now we look to factor since it's already equal to 0. So I look for a GCF. Technically, we need to factor out a -1. We can't have our factors, our parentheses or whatever we're trying to factor start out negative. It doesn't work well, especially when we're trying to make an x by using the trinomials, which we will. So I'll factor out a -1 and get positive t to the fourth minus 72t squared minus 225. I am okay with these being negative, not okay with my first term inside being negative, or the first term I'm starting with. So now since I have 3 terms, I will make the x. And if I make the x here, negative 225, negative 72, let's see what would work. That would be negative 75 and positive 3. So I'd have -1, and I can use my shortcut since it's a 1t squared. So that would give me t minus 75 and t plus 3, t squared minus 75 and t squared plus 3 because it's half of that exponent. Now I can set each of these equal to 0. -1 cannot equal 0, so I can move on. T squared minus 75 equals 0. And t squared plus 3 equals 0. If I work on solving this middle equation here by adding 75, I get t squared equals 75. And the other one, I subtract 3 and I get t squared equals -3. In each of these, I would work on square rooting next. I can realize in this far right equation that I'm going to get imaginary answers, specifically t equals plus or minus I squared root 3. I can rule that out because I can't have imaginary numbers of years. And so then I can have t equals positive negative, as this would simplify to 5 square root 3 square root of 25 times square root of 3, which is 5 square root 3. So we can't have the negative version either for years, so I only have the positive. So my answer is 5 square root 3, but that's not very helpful when we're talking about a number of years. So we'll approximate that. And it is approximately 8.67 years when you round to the nearest hundredth, 2 decimal places. And that'll wrap up this section of Algebra 2, which was 5.5.